Hello class, so this is the midterm review from questions from the textbook. So let's look at the first question here. This is in the order of how it was printed. I believe this is from page, in this way, 157 and going down this way. All right, so let us going back to this question and then look at this question together. So first we are looking for discontinuity. That means we have to realize that definition of continuity first. As x approaches particular value a for the function f of x, if this happened to be not equal to f of a, then we realize that there's a discontinuity. So first point which we like to look at is maybe about 4, because this is a piecewise function. Then about 4, the limit, in order for us to evaluate the limit, what we end up getting is this. Limit of the function of f of x as x approaches 4. Now we have once when we're looking at one-sided limit, from the right has to be equal to the limit of the function as x approaches 4 from the left. Now, and if you think about it, as the fact that we are coming from the right side, what does that mean? X value has to be greater than 4. So in fact, this f of x can be rewritten now using the bottom one, 7 plus 16 over x. Now, likewise, once you look into this one, the fact that x has to be a bit less than 4, then it is coming from the upper value, 2x plus 3. So we just have to evaluate this one. Now, we know that at 4, this particular values are continuous individually. So what we can do is simply substitute the values in, and we will be able to get our answer. So when you plug in 4 here, we'll end up getting 7 plus 4. And is that in fact equal to, we don't know, when you plug in 4 here, it becomes 8 plus 3. So we realize that 11 is on each side. So we realize that it is continuous when x equals 4. Now, to check upon f of 4, we just have to redo the value here, but that will be also equal to 11, so we know that that is true. So 4 is not the point of discontinuity, but if there's, and is there anything else? Ah, that's right. You might be concerned about this one. You will realize that when x equals 0, this portion will be not continuous. But when x equals 0, that is not part of the domain that has been described. So therefore, this will be cancelled because of that reason. So is there any point? No, there isn't any. So the correct answer will be none for the first question. All right, let's look at the second one. We need to find the constant k, if possible, that will make the function continuous. So we're going to use the definition earlier. It is given. This will be the definition once again. Now, then if you two, I guess maybe what I'll do is I'll just copy this once again and bring it over to the next page. The fact that it is continuous, that means this one. I'm just going to put this one on the side. All right. Now, given that, yes, technically what we have to do is we have to use the limit in case of a, then limit from the left as x approaches 1 from the left, meaning left, that means x has to be less than 1, then we are looking at the upper value, 7x minus 2 has to be equal to limit as x approaches 1 from the right. That means we're looking at the bottom value, so we have k x squared. Now, when you plug in 1 for each individual one, we'll end up getting 7 minus 2 has to be equal to k. Then obviously k then will be equal to 5. All right, that's A. B. You see the first logic will be same, so I'm just going to start from the limit concept here. Limit. And once again, we're not looking at the f of a, because f of 1 would be the upper value here. So we don't have to redo that again. Limit as x approaches 2 from the left. That means we are looking at the upper value, so we have kx squared Now, has to be equal to limit from the right, x approaches 2 from the right side. That means we are looking at 2k, 2x plus k. Now, once you plug in those two values, we get to realize here 4k must be equal to k plus 4. Then we get to realize 3k would be equal to 4, therefore k then will be equal to 4 over 3. All right, so let us continue to the next question. Here, we have to evaluate this limit. Then you will realize that in order for us to evaluate this limit, we have to realize what's happening to this inside inner expression. So in fact, you will realize that limit as x approaches positive infinity for the inner expression, which is pi x over 2 minus 3x. Now, we can use the technique where top and bottom has the same exponent. We just have to get the, that's right, we just have to get the coefficient of those two x values. Or if you want to just go a bit further, if you divide by x on each side, then this would have been equal to limit as x approaches positive infinity. That's equal to pi over, oops, no, not equal to, pi over 2 over x minus 3. And you will realize that as x approaches infinity, this portion will be equal to 0. Hence, we will end up getting negative pi over 3. That means the inner portion will approach negative pi over 3. So this will be, in fact, equal to sine of negative pi over 3. Now, then sine of pi over 3, we realize that that is equal to radical 3 over 2. But since we have negative pi over 3 over 2, since we are looking at sine of negative pi over 3, then we will end up getting negative radical 3 over 2. All right, let us continue. Here, in order for us to evaluate this one, I'm going to just share one thing quickly. Limit, as we all know, sine of x over x. As x approaches 0, we get to realize that that is equal to 1. Notice this angle, in fact, is equal to the denominator. Here we have this angle 3 theta is not in fact equal to theta, so we have to multiply top and bottom by 3. Then you get to realize that yes, this should resemble this one, given that x can be equal to 3 theta. Then this portion will approach 1. For 1 times 3, we end up getting 3 will be our answer. Now number 23. Here we have, now if I were to rewrite this one, what's going to be happening is this. This will be equal to limit as x approaches 0 for tangent theta is sine over cosine. So I'm just going to put a long thing here. This becomes sine of 7x. Now I'm going to intentionally leave the bottom blank over cosine of 7x times the denominator. Here we had a sine of 3x. You see, one of the reasons why I have done it this way is because to make, let me try to go back to the previous question here. To look into this identity, as long as the angles are the same, then sine of particular angle over the same value will be equal to 1. So what I'm going to do is this. I'm going to make that happen, this will be equal to 7x. Then if I multiply denominator by 7x, then I have to multiply the top by 7x. Likewise, here if I multiply, to make this one to be equal to 1, if I multiply that by 3x by top, then I have to multiply denominator by 3x. Then what will end up happening is this portion would be equal to 1, the sine of 7x over 7x. And this will be in fact reciprocal, but also 3x over sine of 3x will be also equal to 1. Then you will realize x cancels out with this x. So then this will simplify as to limit as x approaches 0 for 7 over 3 times cosine of 7x. But as x approaches 0, cosine becomes 1. So this ends up being 7 over 3. Now, some of you guys would have just looked at, hey, wait a minute, tangent of 7x and then sine of 3x works similar in this manner. So you're just going to take the 7 over 3. That would have been also okay, but that can be dangerous in more complicated questions. But this will be more defined derivations of the solution. All right, let us look into number 27 together. Here we have 1 minus cosine theta. Then if you have to plug in theta into 0, then you will realize the top and bottom will be equal to 0. So you will realize that you will have to do something. One way which we can do is factor, but there's nothing much to factor. Another thing which we could have done was multiply by its conjugate, 1 plus cosine theta. Some of you guys might have memorized this identity already, but we'll try to look into this one together. Then here we have the limit as theta approaching 0. The numerator becomes, I'm going to write it as theta squared times 1 plus cosine theta. Denominator becomes 1 minus cosine squared theta. You see, because of the difference of perfect squares. Now, but this then becomes limit as theta approaches 0. Now I'm going to rewrite down the theta square as theta times theta intentionally. And I'm going to rewrite 1 plus cosine theta. Now, how about the bottom? 1 minus cosine square, in fact, is equal to sine square theta. By the sine square plus cosine square equals 1, that Pythagorean identity, 1 minus cosine square becomes sine square theta. So I'm going to rewrite down the sine square as simply sine theta times sine theta for us to see better. Then here we have this portion is equal to 1. This portion is equal to 1. Therefore, we only have 1 plus cosine theta left. But as theta approaching 0, we end up getting cosine theta becomes 1 once again. So therefore, our final answer becomes 2. All right, let us look into the next question. Now, once again, this one has to be continuous. Then this is the same idea as before. The limit from the left and limit from the right has to be the same. Then, in this case, limit, and also f of 0 has to be also all equal to each other. Limit of the function as x approaches 0 from the left. That means x has to be less than 0. That talks about the top portion. So we have tangent of kx divided by x. We have to use that expression. Has to be equal to limit as x approaches 0 from the right. That means x has to be greater than 0, which gives us 3x plus 2k squared. Now, then you could have seen this one from previous question, that this simplifies into simply k. In order for you to derive this one, you can use the tangent kx as a sine kx over cosine kx. Then you should be able to see it. Then on the right side, if you have to plug in 0, then we end up getting 2k squared. Now, since non-zero, that's the k values, then what's going to be happening is we can bring this one over to k over to the other side. 0 equals 2k squared minus k. Then by factoring out k, we have 2k minus 1. Now, since k cannot be equal to 0, Only way for us to make this expression equal to 0 is 2k minus 1 has to be equal to 0. Then it tells us k has to be equal to 1/2. All right, let us move on to the next question. All right, so we have a particle moves on a line away from its initial position, so this is the s equals 3t squared plus t. That's the position function. Now find the average velocity. How do you find the average velocity? That's simply the equation of a slope. So we have s of 3 minus s of 1 over 3 minus 1. Then here we end up having, when you plug in 3 in place of t, we end up getting 27 here, plus 3 becomes 30. And if you have to plug in 1 here, we end up getting 4 all over 2. Then which we end up getting 26 over 2 becomes 13. Now here we end up getting 13. Let me just rewrite it. And then, since the unit will be miles per hour. All right, number B. Find the instantaneous velocity. How do you find the instantaneous? That's the derivative. So we have to look at the s prime, or which is the velocity, which becomes 6t plus 1. Now, when t equals 1, then we end up getting, this becomes 7. So therefore, 7 miles per hour. Now C, find the value where the instantaneous velocity is equal to, this is the mean value theorem. So we realize that we're going to be using the part A once again, because the expression should be that s of 3 minus s of 1 over 3 minus 1 has to be equal to s prime of C. And we have to figure out what the C value would have been. Since we know that the left side is equal to 13, well, only thing that we're going to be doing is, this will now translate into 13 is equal to 6t plus 1. And here you can easily see that t must be equal to 2. So it's 2 second hour, 2 hours. That's basically what we're looking at. All right, let us look at number 23. Match the graph of the function shown in small letter a through f with graph of their derivatives, a through f. Now, let's look at a for a second. Now, then, for example, we are looking at this function here. What would be the derivative? Initially, I have positive value, and then all of a sudden, the slope is positive constant value, and then all of a sudden, just slope is 0. So I'm looking for positive value, and then positive constant value, and then has to be 0. That's got to be choice D. How about next? B must be, it's a negative, positive, negative, positive, but same value is repeating. Only thing that's possible would be choice F. Negative, positive, negative, constant value because it's linear, but changing its position. Now, number C, green one. We are looking at a horizontal slope at 0, and then slope is increasing, and slope is decreasing. So slope has to be positive and negative. In the middle, it has to be equal to 0. Positive and negative, so it looks like choice P. Now, choice D, we get to realize that slope is almost at 0 and then decreasing to the negative infinity. But on the other hand, from positive infinity, we have to approach to 0. So only thing that's possible is choice C. Now, next one is choice E. It means triangle. Here we have left and right side slope is equal to about 0, and the middle has a slope of positive values, which is only possible with choice A. That only gives choice F. for E, let's see if it makes sense or not. Left side, the slope seems to be positive infinity. Right side, the slope is negative infinity. Where slope in the middle is equal to 0, and that makes sense for choice E. All right, great. So let us move on to the next question. This is the given values where g prime of 2 is equal, we need to find g prime of 2. Now, so g, given that is equal, g of x is equal to this way, then g prime of x, by the chain rule, 3 comes out, and f of x, and square, and then by the chain rule, we have to multiply by f prime of x. Now, the fact that we are looking at 2 in place of x's, so g prime of 2 becomes 3 times f of 2. Notice this is just f of 2, not f prime of 2, multiplied by here. This will be f prime of 2. Now, then what is this equal to? Let's try to calculate that. 3 times. What is f of 2? F of 2 is, in fact, 1. Times, what is f prime of 2? F prime of 2 is 7. So therefore, our final answer becomes 21. Let's look at B. H prime of 2, where, now in this case, H prime of x becomes, by the chain rule, we have to get first f prime first, of x cubed. But because of the chain rule, we have to multiply that by 3x squared. That's the derivative of inside. Then, what is h prime of 2? That's equal to f prime of 2 to the third power, which is equal to 8, times 3 times 2 squared. Then here, what is f prime of 8? F prime of 8 becomes negative 3. And then here becomes 12. So we end up getting negative 36. That becomes our final answer. All right, let us move on to the next question. We need to find the derivative. Here we have chain rules here. Then f prime is equal to, all right, so derivative of tangent becomes secant squared, but you have to leave the inside alone first. And then you are looking at the chain rule. What is the derivative of inside? It becomes 8x. So in fact, that becomes our answer. That's it. How about number 15? F prime becomes derivative of sine, which becomes cosine, of the inside value as they are. Now, we have to multiply it by derivative of inside. What is that? Now, if you have difficult time, you can imagine this one to be x to the negative 2. Then you will easily see that this must be equal to negative 2 x to the negative 3 power by the power rule. And if you have to rewrite this one, we get negative 2 cosine of 1 over x squared whole thing over x to the third power. That becomes our final answer. All right, let us move on to the next question here. Using the graph of the equation to find the sine of dy over dx and this one at point A, B, and C. Here, since the derivative, meaning what? Given that the function is the original function, the first derivative is the slope and second derivative is the concavity. At A, f prime, the first derivative is negative because it's going down, but the second derivative is positive because of the positive concavity, meaning we still cup up in this section. How about B and C? B, the f prime, is positive because going up, but double derivative is negative because it's cupped down, negative concavity. How about C? In case of C, first derivative is negative because it's going down, so is the second derivative because of the negative concavity, it's cupped down. All right, number 5. Now we are looking at double derivative here. to determine x-coordinate of the all inflection points. Inflection point meaning where the second derivative has to change its sign. All right, that means where do you see that? Here we see that because before it was positive, now it's negative. So we are looking at -1, and here too, because negative to positive, so 0. And here 1, and here 2. So that becomes our answer. How about this one? We're looking for, this is the first derivative. Now, between f of 0, which means right over here, we need to basically make sure which one is greater or less or 0 are equal to each other. F of 0 versus f of 1. Y values, of course, this one is greater. B, between 1 and 2, of course, 1 is greater. And f prime of 0. F prime of 0 is, you see that it's negative slope, so it's going to be less than 0. F prime of 1 is still negative, meaning slope at, oh, my bad, actually, this one has to be, I misread. Redo, this is the graph of f prime. Sorry about that, guys. Okay. Now, then let's try to redo this one more time. F of 0, which is right here, this particular value, and f of 1 is this particular value. You see, since the derivative is positive all throughout, that means the function has been increasing as you're going into f of 1, given f prime is always positive. So f of 1 is greater. My bad. And before I misread the label of the function. Between f1 to f2, in fact, f1 to f2 is the first derivative is negative because it's below the x-axis. The fact that first derivative is negative between those two values, then the function has been decreasing. Therefore, f of 1 is still greater. Now, how about f prime of 0? F prime of 0 obviously is a positive value. So therefore, it's greater than 0. F of f prime, we can just read it off from the function as they are. F of 1 is crossing the x-axis, therefore they're equal to 0. And f double prime of 0. F double prime from f prime is this becomes the slope of f prime, you see? Double derivative also can be used as many times by concavity. Yes, it is concavity of f, not f prime. You see, these two means the same thing. So therefore, when you look into the f double prime, then I'm actually looking for the slope of f prime at 0, which is negative. So therefore, we are looking at less than 0. And then we are looking at f double prime, meaning what? Slope of f prime at 2, it seems to be about equal to 0. So we're just going to call it equal to 0. All right, let us move on to the next question. Now we have, actually we have many questions left. So I'm going to stop now and we'll continue in the part 2.